All right, so we're now moving into integration, which is really a lot of people refer to it as antiderivatives. Okay, which is actually another name for it. It's antiderivatives. So basically, what I'm saying to you here is that what we have f prime of x is equal to this. Okay, and so then the question is, f of x is equal to what? What do I put here so that when I take the derivative, I get back this piece? Okay, so what we kind of discussed was that if the derivative ends up as x to the third, then you must have an x to the fourth here. And that's the way that when the 4 comes down and drops by 1, that will end up with an x to the third. Okay? But the problem that you might have noted was when the 4 comes down, it don't make x to the third, it makes 4x to the third. And then what do I do with the 4? And so that created a rule for us, which I'm going to give you now. That created a rule for us, right? So what we said is that we have this rule that is the integral of x raised to a power, that the integral of this with respect to dx. Now the dx is one of those things that most people just don't even pay attention to it. And if I didn't put it there, people are like, well, I don't care. I don't really need it anyway. Like, it's definitely like the crust on the bread. No one really needs that. All right? But we created this rule that said that this was equal to x raised to the n plus 1, and then we were going to divide that by n plus 1. So the rule was whatever exponent you have, add 1, and then let's just say it. Copy and paste it from there to the bottom. All right? And the world of applied calculus is all done through copying and pasting. Whatever that number is on top, that number goes to the bottom. Okay? So as I do this, what I have is x to the fourth increased into 3 by 1, x to the fourth, and then taking that and putting it over whatever that exponent is. When you have 3x, that becomes 3x raised to the, this is a 1, so that becomes a 2. Does that make sense? That's a 1, this becomes 2, and then you got to divide by what? You got to divide by 2. You divide by whatever the exponent is. Okay? This becomes 2x, and then recall that there has to be a plus c on the end. Okay? The c is because if I take the derivative of this, the 4 drops down, you get x cubed. The 2 drops down, you get 3x. The 1 drops down, you get 2. And if it's a constant, it just goes away. So when I say that this integral is x to the n plus 1 over n plus 1, I should make a point to say that that is equal to that plus c. Now, students will ask me, if I don't put the c on it, are you going to mark it wrong? I mean, if the Gators win, probably not. But if we lose to Florida State again, 100% sure it's going to get marked wrong. I'm going to be mad. All right? Now, you guys are lucky because the class is going to end before Florida State plays. But, future classes, yeah. You better be rooting for the Gators. Okay? I actually had a teacher who marked off because I didn't put C, and they marked all of them wrong. Every single one of them. And then they let me retake it. And I was like, thanks a lot. Thank you for just wasting my time. You know I know the answers. Oh, I know you do. Jerk. Okay. So what is this one going to be? What is this one going to be? Any ideas?
I raise it to the 1/2.
Okay, so that's exactly what you want to do, right? What you want to do is take this and say that this is equal to this, but this is x to the 1/2, right? And now what are you going to do?
Add by one, put it on the bottom.
You're going to add 1 and put it on the bottom. Now, when you add 1, like it seems so easy, like, oh, just add 1. Well, 1/2 plus 1 is 3/2, yes? But then you got to take that and put that over what?
3/2.
Over 3/2, right? Which is equal to 2/3 x to the 3/2. So when you divide by a fraction, you multiply by the reciprocal. That's just something important to know. Okay. What's that? Shit. And you can see I've never gotten better at this stupid plus C's thing. I mean, I always forget it. Okay. As we do this one, we got what amounts to 5/2 x squared. Yes. Minus 4x. Minus 3/4 x to the, or 3 over x to the 4th. Okay, now why is that? Because that was kind of just done like arbitrarily. So let's make a note on that and then we'll get out of here for today. Note that 3 over x to the 5th, which is what we have, right, is really equal to 3 to the x to the -5, yes? Now the rule is what? The rule is add 1 and divide by that, yes? So the rule is take this, add 1, and then divide by whatever this exponent is. Right? All right. So this -5 plus 1 is -4. 3x to the -4 all over -4. We agree? Which gives us -3/4. -3/4. The x to -4 would go to the bottom. Okay? So this is kind of the foundational integration stuff. Now, we're going to take this and put it on steroids tomorrow. And then also go over, all right, so now that I found the integration, now what? Like, what does that do for me? Because right now it just seems like all it really does for you is just cause a headache and make you want to quit. But it's actually a very useful tool, but you got to join me tomorrow or whenever I see you again, for those of you watching at home, for why do we use it and how does it work? All right? With that being said, we're out of time.